You feel the universe trembling, as if reality itself is trying to whisper a secret. The sky above you seems still, but something ancient is moving, something powerful enough to bend time itself. A deep, invisible wave passes through everything, your body, the earth, even the light in the sky. And no one notices. Except one man, 100 years ago, who predicted this moment long before humanity could even imagine it. He was Albert Einstein, the man who saw beyond sight, who dared to claim that space and time were not solid but soft, flexible, and alive. In 1916, he wrote down an idea so wild, so impossible, that even he wondered if it could ever be true. He said the universe could ripple like water, that colossal events in the cosmos could send invisible waves across creation itself. For a century, scientists called it a dream, but in the end, the dream called back. In 1916, Einstein published his general theory of relativity, the idea that gravity isn't just a force pulling things together, but a warping of space and time caused by mass and energy. According to him, when massive objects like stars or black holes move or collide, they create ripples that travel across the universe, what he called gravitational waves. But back then, there was no way to prove it. No telescope, no technology, no evidence. It was an idea far ahead of its time, so advanced that even Einstein himself doubted if humans would ever be able to detect it. And yet, the universe never forgets. Fast forward to the year 2015. Somewhere deep in the American desert, at a secretive facility known as LIGO, two massive tunnels stretched out for miles. Inside them, lasers bounced back and forth between mirrors, waiting for the slightest tremor in the fabric of space itself. For years, they saw nothing. Only silence. Then, on a quiet September morning, the silence broke. The computers detected a tiny vibration. Something had rippled through the earth. Not sound, not light, but space itself, stretching and shrinking for less than a second. The scientists froze. Could this be it? After 100 years of waiting, had they finally heard the universe speak? They ran the numbers. Two black holes, each 30 times the mass of the sun, had collided more than 1 billion light-years away. The explosion released energy equal to 3 suns turning into pure gravitational waves in a single instant. Those ripples traveled across the universe for over 1 billion years before reaching Earth. And yes, they matched exactly what Einstein had predicted in 1916. Einstein was right. For the first time in human history, we didn't just look at the universe. We heard it. The signal, known as GWM-914, was a faint chirp, a sound so short and small that it lasted just a fraction of a second. Yet in that instant, humanity crossed into a new era. We had proven that space-time, the stage on which all reality plays, could move, bend, and sing. Think about that. Space itself can ripple. For scientists, it was like discovering a new sense, like suddenly being able to hear after a lifetime of silence. For everyone else, it was like hearing the heartbeat of the cosmos. But here's what makes it even more poetic. Einstein himself once said he wasn't sure if gravitational waves were even real. He thought they might be too weak to ever be found. And yet 100 years later, human, with tools made of light and mirrors, caught them. It's as if time itself waited for us to catch up to Einstein's imagination. After that first detection, everything changed. LIGO began hearing more and more signals, colliding black holes, merging neutron stars, even the faint echoes of the early universe. The data didn't just confirm Einstein's theory, it expanded it. Every new wave carried a message from the most violent, mysterious corners of the cosmos. It's easy to forget what this means. A century ago, Einstein made his discovery using only his mind. No supercomputers, no telescopes, no satellites, just pure thought. And today, his theory allows us to detect events that happened billions of years ago. His ideas stretched not just across space, but across time. Scientists are now building even more powerful detectors. The Einstein telescope in Europe and LISA, a space-based observatory that will orbit between Earth and the Sun. These instruments will listen to deeper, fainter, and older waves, maybe even from the birth of the universe itself. We are no longer silent observers of space. We are participants in its song. Einstein's impossible theory didn't just change physics, it changed how we see reality. It told us that space and time are alive, dynamic, and responsive. That we are part of a universe that moves, breathes, and evolves. When those black holes collided a billion years ago, life on Earth was microscopic. Dinosaurs hadn't yet existed. Humanity wouldn't appear for millions of centuries. And yet the waves from that event traveled all this way, only to reach us at the exact moment when we had the intelligence to notice them. It's almost as if the universe had planned it. Einstein once said, "The most beautiful thing we can experience is the mysterious. It is the source of all true art and science." He believed the universe wasn't random, it was poetry, written in physics. And now, his century-old dream has become humanity's greatest truth. So tonight, when you look up at the stars, remember, the space between them isn't empty. It's alive with motion, with stories, with echoes of ancient collisions. And somewhere in those waves, Einstein is smiling. Because 100 years later, the impossible became real, and the universe finally whispered back, "You were right."